Next person coming. I'm not having a CV, but it's actually not necessary because he was a student at my university. Did you ever work with Marcel? I think so, eh?
No?
Actually, no? You didn't? Okay. We have, quite some workshops in Delft which are pretty much into doing practical things, and then these guys came and wanted to start their company, and we yesterday talked again about this. I didn't remember what I commented, but it was interesting to see. So they want to do something, they want to build something, and then they start, and then 3 years later you came with your first mock-ups, which are still on my Windows shell.
Yeah.
And you showed what you are able to do, and that's interesting to see how they say these younger companies are really pushing into it. And now, you're very good at also posing things. I'm going to be interested to see what you're going to do now.
Cool.
The horse is yours.
So 3 years ago, we were also looking at sort of what's going on, because 3D printing sounds like a great solution for sort of the waste and the sort of making unique things. And indeed, at the time also, everything was mainly extrusion based, like we're seeing here today. And we thought, you know, it's a quite difficult proposition to do this, because you're competing with the sort of precast industry, which is highly efficient. You're making structural parts which will be hidden in the end, so you're purely competing on volume and on price. And we thought maybe it's interesting to go for a different approach and not do this sort of extrusion approach and not go for sort of volume, but try to go for more quality, really form freedom, and not sort of limited form freedom that you have with extrusion, and try and go for a truly sustainable material. So I think that makes us a bit different. So we really do binder jetting, and our goal as a company is to ultimately go for really autonomous production. And so we call what we do stone 3D printing. We do this sort of very highly detailed mineral production, where we work with a couple quarries in Italy, but also in Belgium, and we take sort of the cuttings from marble or granite, this sort of fine dust. We mix it with their own minerals, and it goes into our sort of binder jetting 3D printers. So this is an example of using marble dust together with an Italian partner, sort of making a highly detailed ornament. These are some examples of lamps that we're doing together with a label, where we're also using a limestone powder. Sometimes they mix together with pigments, to create these sort of very detailed elements. So we developed this printer. At the moment, it's fairly small scale. One batch, 34 liters. It's a standard binder jetting procedure, so you really jet an ink on top of thin layers of powder. Both the ink and the powder are fully tuned together. It's a completely mineral process. There's no OPC. There's no glue, there's no resin, there's no epoxies or these kinds of things, no plastics. And you know, what you get is really these kind of components. So like with any kind of 3D printing, there's a custom slicer involved, where you see the print box, you can just load in multiple parts together. You know, you choose a material. So the standard materials we have are basically granite-based, limestone-based, and marble-based, and we have one heat-resistant material for mold making, for example. So you load in the material, and then it's really click print. So there's no G-codes, whatever. The software slices it into thin, into slices that are just image files. So there's no, you don't have to sort of make tool paths. It's really a box in which you can load a multiple STL or OBJ files together. And then you click print. So after printing, it's depowdering. We fully recycle all the powder we use. And after printing, all we do is we dip it in water. And if it's for exterior use, we give it a sealing. And we use the same products that you would use to seal concrete or stone objects. So to give you an example, this took 2 hours to print. Compressor strength is about 20 MPa. And we fully tested it against all sort of moisture, heat, fire safety, these kinds of things. And so I want to show you for me, quite interesting project. It's very small, 23 bricks, or kind of windowsill bricks that were missing in this renovation project in Amsterdam. So they didn't have the mold to remake these bricks anymore. And it turned out that it was actually cheaper to directly print the bricks based on a 3D model than to remake the mold and do a casting of those bricks. And I put the price there. We sold it at 45 euros a liter, which is a lot for a brick, but it actually still made sense for the contract to do it this way. So I think it's a really interesting way of sort of adding value with 3D printing. Yeah, it's quite simple. So we just made an STL file, printed it out. In this case, they wanted it in black. They gave it a small ceiling, and they put it inside the building. So it's the same process as they would normally use, but just faster and cheaper, which is super interesting. So what we offer, mainly we try to sell our printers. So we have this kind of, it's called the armadillo, because an armadillo also has layers. And this is a production 3D printer. So with this printer, you can print basically in 3 standardized materials. Do with any shape you want, there's no supports necessary. And the cool thing about binder jetting is that you can actually do quite a big volume. So this is a small machine, but it runs 3 batches a day, so you can print about 100 liters a day at a cost of about 10 euros a liter if you're a customer, which is the cheapest on the market if you look at this quality. We can do it cheap because the actual input materials are very, very low cost. So yeah, I mean, this is it's on the market, and this is the sort of other version of this printer. So while we were developing the machine, we actually started with an old Z-Corp machine, sort of tweaking materials and this kind of tools, and you realize how sort of limited and closed off existing binder jetting printers are. So it's very difficult to change inks or change powders and adjust the software. And what we actually needed in our sort of development is to have a tool in which you could tweak those materials, you actually steer material properties. And we realized, like, I mean, we're doing these kind of stone-like materials, but you can actually also use these tools to do polymers or metals or ceramics. So we decided basically to make this as a platform available to the market. So this is a tool where you can change everything. You can adjust the binders, adjust the powders, etc., and you can really develop your own materials. So it's quite a large tool for what it does, but it's excellent for that. And so, indeed, mainly we focus on putting these machines in the market, and we also do some projects. And I'm going to show you 3 or 4 different projects, all to do with sort of different ways of connecting these parts, which is ultimately necessary to go to larger objects. So this is a kind of statue we did together with the University of Innsbruck, this research group, where it's a 2.5 meter tall, 700 kilo statue, highly detailed, where we printed in 40 different batches, 40 different blocks that are all connected together to form this kind of very intricate shape. And I think what's interesting is these the sort of blocks you have. So there's 40 different blocks, all very highly detailed. And the connections are fully integrated in the geometry, right? So there's the turtle on the right is part of the base of the statue. And there it's really puzzle pieces that are interlocking. You can see that it's hollow to save some weight. And on the left you can see the detail that you reach. So we typically print at about 300 micron layer height, which is enough to get a fairly smooth surface. And for us, this surface quality is really important because we don't really see it as a structural thing. It might become that at a later stage, but we think we can have the most value more as a finishing or as in really providing unique solutions to certain projects. So this is what it looked like in the van on the way to Austria. So it's 40 different pieces, and this is how it is stacked together. So you can, I think it's really cool that it shows you basically the intricacy and the sort of level of quality you can reach with this kind of thing. And so in this case, they actually wanted to have the lines visible. So it's part of the design decisions that they made. So they sort of like the idea of sort of just stacking the blocks. And in this case, there's just one steel beam through the middle that holds it all in place. And this is another project. This is actually downstairs, this sort of large coral shape, together again with Austrians, accidentally. But I mean, these guys, these researchers, they're really studying sort of growth patterns and algorithms of corals, mimicking this sort of natural growth behavior. It's also larger than the batch size of the printer. So this is what it looks like. This is how it is at the stand downstairs. But also in this case, it's 16 different prints connected together. And what we did in this case to connect is, it's quite simple. It's taking the powder, making a slurry, and sort of manually closing the gaps between the things. So I think this was maybe 2 days of production. And again, you see the kind of detail and complexity you can reach with this technology. This is a small case study we're doing together with a prefab factory to sort of look at applications in lost formwork. So just printing shells, where the shell is the finish in itself, and all you do is cast in a reinforced concrete. So this is very early stage. We don't have that much detail about it yet, but I think it's quite an interesting way to also create high-quality surfaces that can really be assembled on-site. And then lastly, the project I would like to share is this project we did together with the code group of Zaha Hadid, and as well as a few other interesting partners, where we're working on prototyping basically these structures. So this is a pavilion that is meant to be, I think in the end, about 5 meters tall, and right now we're in the sort of prototyping process of it. So this is how we presented it at Dutch Design Week a couple of weeks ago. We used a sort of slightly beige limestone-like material to produce it. And I think what's interesting is that you load, I think it's about 4 prints in total. So 1.5 days of production, just doing all the different parts together in different batches, having integrated connections between the sort of, I think, 21 different pieces. So they really have a tongue and groove connection. They're only about 1.5 centimeter thick. And then the structure itself, here you can see actually the tongue and groove connection. So here is kind of tongue, and they all slot in to these grooves. And they were built up like that. We had to use a mold for it, unfortunately. But then the structure is fully based on compression. Well, I'll show you later actually how that works. The texture, I really like it. It was interesting at the fair, people were comparing it more to suede than to stone, which is interesting. So you can see, you kind of see the sort of lines of the printing, a bit visible, but not very clearly. And this is, I think, quite a lovely, almost wooden texture. And so yeah, here, so the structure is fully based on compression. Just here, there's a tension cable around it, and that's what basically holds the whole thing together. So in this animation, you can see what would happen if there was no tension cable, if it actually plays. No. Well, in any case, it would collapse. So this is quite a nice detail actually of the cable sort of embedded in the model itself. And again, I think you can see the textures of it. And here again, you can see this kind of tongue and groove connection. And what's cool is that the whole thing stands actually at this sort of very small base. Indeed. So yeah, what we do now, I mean, we put printers in the market. We also collaborate with interesting parties to make projects. And I think you just asked the question to the previous, what is the main challenge? For us is indeed building bigger printers. It's ongoing. Because indeed you need scale to do the most interesting stuff, especially in the construction market. But yeah, so we chose a different route than the typical extrusion path, but we think it's quite an interesting path. Thank you.
Thank you. Then obviously I directly have the first question. So what's the maximum size you can imagine? You have the money you need, what would you build?
Yeah, I think there is a theoretical maximum where you're dealing with handling. It's about 4 meters by 2 meters, something like that. But I don't think that is even the most interesting commercial side. I think the most interesting commercial side is you have 6 printers that are medium size, maybe 1.5 meter, and just connect parts, integrate connections, integrate functions. I think that is the most interesting.
In my glass world, we always were limited to the dimension of glass float production, 3 meter by 6 meter.
Yeah.
And now we have 3 meter 60 by 20 meter.
Yeah.
And imagine a glass plate of 10, 12, 15 centimeter, that length. That's a handling nightmare.
Exactly.
But the Apple stores, they pay for it. So think big, man. Okay, question to him. Yeah, here we go.
So how we do, we basically directly after printing, so within 3-5 minutes, you can take it out of the printer. Then we depowder, dip it in water, and then it continues to gain strength for 2 weeks, I would say. But you can handle it after 1 day, basically.
Second question.
Do you think this would be an issue when you scale it up? And can you also directly take out a bigger part, or will it collapse on a certain way?
As it did.
Yeah, no, so it's something to take into account when engineering, indeed, but so far it's not been an issue. I think the green strength is good enough to handle. You have to be a bit careful, of course, but you can handle it quite well.
One more? Here we go.
Which kind of binder do you use?
We don't share.
Come on, he's professional, of course. Well, he was getting a side of that information all the time. So I was expecting this question. No problem, fine. Thank you for being here, thank you for presenting, and I'm going to ask you again in 3 years' time, and then I want a big one. Thank you.
Thank you.